So welcome everybody. Thank you for attending the Cleveland Big Data Meetup, November 16th, 2020. We've got three great talks today. From first up, Tamera and Ken on extending AIOps to the enterprise. Luke Teeters up second with the DNS defense in depth, and Arista Networks will be up in the cleanup position for Arista Awake Security, the AI-driven security transformation. So again, speaker's preference on questions, if how they want to handle the questions during the slot, but these are 20-minute slots. So a few other minor announcements before we get started. So for those folks who've probably noticed, there's a member approval process. I had to do this because we were getting drive-by spam on the comments earlier in the year, and that definitely cut down on the comments, because the pattern was, you know, a new member would come in, they'd spam a lot, and then they'd leave, and so it was never obviously a single member. What this did introduce is, unfortunately, I do need to approve each member, and I do actually check out the profile of each person to make sure that person's real, because some of them are not real people. So I've asked a few questions of people, of like, you know, how'd you get interested into the group? Do you have a LinkedIn profile that you could point me to? And again, if there's anyone that is a real person that felt like I was being a little hard on them, I apologize. I'm just trying to reduce spam, because even with the explicit approval process, I still get accounts that you can kind of tell are not actual real people. So some of the ones I'm watching a little bit closer are like, you know, first name only, or just gibberish names, or things like that, or people that basically are like in 100 meetups. I tend to check those out a little bit closer. So again, apologies to real humans who have a desire to learn about big data, but I'm just trying to protect all of our emails, and the sanctity of the content. The other one is a friend of the show. It's a long-running gag. But once you do a presentation for Cleveland Big Data, you become a friend of the show. It's a very valuable title. It's more like a life peerage. You keep that for life. You can't gift it to your children or will it to your spouse, but you do get that for life. And I'd like to point out that Arista has been a longtime friend of the show. Thank you.
You're
God,
welcome.
6-7 years.
Yeah, it's been a long time.
Yeah, Arista's been doing talks for years. So I just wanted to call that out, because sometimes I forget to mention the friend of the show part. Again, it's much appreciated, and it's what keeps the meetup coming. So if anyone has a desire on being a friend of the show, please let me know. Message me. If anyone has any other topics that you'd like to see, also please message me, because again, new content, new speakers, plus old friends makes for a great meetup. And I had another announcement for January 2021. Paco Nathan, the Paco Nathan, is going to be doing a talk. So he's a well-known O'Reilly author. If you've ever seen the O'Reilly series, Just Enough Math and things like that on NLP and machine learning and AI, he's a fantastic speaker. So we're lucky to get him in January. And now comes to the, actually on one more. Happy 10th anniversary. Obviously, we celebrated this in September, but I think I had the wrong date. I had October 20th, 2020 in the picture. So here's the first picture once more. So with the corrected date. But yeah, so it was October 20th, 2010 was the first meetup. And also a few thanks. Thank you for the Linux Foundation and John Murdoch for helping us out with the Zoom. It's the Linux Foundation's Zoom account. So please give them a round of applause. Thank you, John. And I'd like to also open this up for the recruiting shout out. That's another tradition. Let's see, John, the last time we did this, we had an issue with the chat visibility. Okay, good. So can we do a global one? Can we let people do all attendees? Hey, John? Okay, so if we, how about this? If you have anything to announce, can you do a chat to the panelists? So if you look at the chat function in Zoom, there should be an option to send it to a panelists or panelists and attendees. Preferably do the panelists and attendees. We'll give it give it a minute or two just for folks to chat up. There we go. So first one, oh, excellent. Thank you, Tim. I didn't realize the option was available. So folks should be able to see Tim Houlihan, panelists and attendees, Centric Consulting. So Tim's got his email right there, looking for a senior data architect. You should be able to see that in the chat. And Chuck Messina, also to panelists and attendees, good. Arista, hey Chuck, can you put your email in the chat?
Will do.
Chuck Messina, Arista is looking for talented engineers looking to join the Arista team in Northeast Ohio or Northern Ohio. There we go. Thank you. And anybody else? Going once, going twice. So first up, I'm going to stop sharing this. And first up is Tamera and Ken. You guys should be able to take control now.
No, not yet.
Oh, one more, sorry. KeyBank's looking for talented engineers and architect. Email Michael_Anders@keybank.com. You guys should be able to see that in the chat. How's it looking now, Tamera?
No, it says you have to screen share. It's not working.
Do you have the share screen at the bottom of the?
I do.
Yeah.
Go in and disable it again. Sorry. One moment, please.
And I wanted to point out something in the picture. Mike Anders, thanks for attending. Mike was actually at the first meetup 10 years ago. So thank you, Mike, for coming back all those years. And oh, we got one more. Gaurav, can you do that? Can you re-chat that to the panelists and attendees? Is that an option for you? From Robert Half is looking for Python developers familiar with AWS. Oh no, the same text that you had before, not the link.
Yeah, unfortunately, it's not allowing me to share.
Did you recently upgrade your Mac?
I did, yes.
It might be a permissions issue.
Actually,
Have you shared your screen today?
It says host disabled attendee screen sharing.
Oh, she might not be a panelist then.
no, I'm a panelist. It should be.
Yeah, I'm a panelist as well, and I can't if I try. I get the same message.
Yeah.
Yeah, you're right. I just tried it. And when I click it, it says host disabled participants screen sharing.
There we go. Thank you. Thank you for your patience. I'm Tamera Chess alongside Ken Czekaj, NETSCOUT. We appreciate you attending Extending Artificial Intelligence for IT Operations to the Enterprise. Thank you for your patience as we got our presentation up and running. So tonight we're going to talk about AI and really what it means on the impact on the enterprise. As we all know, AI provides us insight to really understand our operations. It helps us continue our digital transformation, our IT transformation, and it really helps us continue with the velocity we need to keep up in this fast moving world. AI basically provides us insight. And if we look here at some of the bullet points we've highlighted, we take a look at our call centers. And with AI today, we're really able to take a look at and analyze not only the tone of voice and the cadence of language to really understand that type of call when a call comes into our call centers, but it's really to understand the customer's mood. And if we look at our applications, our virtualized environment, our migration to the cloud, we're able to find out with AI if our applications are agile. And we look at the attacks within our network and the anonymous traffic that we may see within our network. We're able to really take AI and understand the cybersecurity within our environment and what's going on in the world around us. So tonight we're going to dig in and how we use AI, how do we analyze it, and how do we really showcase the data, not only in our environments, but also for the user experience. So with that, I'm going to turn it over to Ken Czekaj.
Thank you, Tamera. Appreciate it. Hi, everybody. Thanks for having us. It's definitely an honor to be here. So we're just going to jump right in, as Tamera mentioned. So when we talk about artificial intelligence and machine learning for IT operations, I mean, in the big picture, we're looking to classify, predict, and decide. And in the big picture, we're going to classify behavior, in this case, the way NETSCOUT does it. It's application, it's network traffic. And while it's traditionally been used for performance management, we create an awful lot of metadata, and a lot of that metadata can be leveraged into AI platforms and machine learning platforms. So things as silly as just, hey, I'm seeing some strange response time issues, to my call center performance is acting a little weird, to why is my link completely consumed. Those are more operational type of things. However, that with those types of metrics, they can also be used for baselines. And not only at layer 2 at a network link, you just raw utilization perspective, but also specifically into the application performance. And when you start looking at today's very complex world in terms of virtual platforms, Citrix platforms, work from home, cloud, software-defined networks, it starts to get kind of crazy on it. It's getting a little blurry between the operational lines of what operations look like as opposed to artificial intelligence and machine learning. Our focus is to leverage a lot of this data so that it can be leveraged, obviously, for operations as well, but also use it more for more predictive and make better business decisions off of this as we go. Get the next slide, Tamera. Thank you. And you may want to have in slideshow mode. One of the things is, again, as I mentioned, we're taking a lot of this data, and the way the NETSCOUT platform works, we're taking it right off the wire. And when I say the wire, it's right off the network traffic. It's a copy of the network traffic, or we're actually tapped into a link. But again, the bottom line for this is traditionally this has been leveraged more for IT operations, more for real-time situational awareness and triage. But again, a lot of this can be leveraged, because the metadata is what we leverage for that platform. It can also be leveraged into other platforms, and we highly recommend that people do that. It's one thing to have this type of very rich information coming off of the wire. It's another thing to actually see it leveraged into other platforms where you can use it to make better business decisions. And we'll go through this, but the bottom line is, as we see the traffic come in, what we do is analyze it. We create metadata, we call it ASI data. But effectively, that's metadata, and that can be leveraged into other analytics platforms, pulled into Hadoop platforms, put in the big data lake. You've got options in how that's leveraged. And it's not just network traffic, as Tamera had mentioned, it's also really the user experience, because in our world, especially for what we do every day, don't usually have customers call us up and say, hey, things are running great, just wanted to say thanks, buy you guys a cup of coffee sometime. And that's how it typically is in the IT world as well. People usually call in when things just aren't working well and they're just not happy with things. So at the ballpark of where we're shooting at here, we want to be focused on the end users, whether that's voice, video, or data. But the bottom line is I take that data in, again, could be response time, could be multi-tier applications, could be voice over IP, could be cloud. Honestly, we don't care. We need to get to the bottom of what's causing this problem. And as we build and take this data in from multiple protocols and multiple different locations, including data centers, including virtual private farms as well as public cloud. Again, having a view into all of that data, not just on the performance side, but also how that actually looks across the enterprise, that's more of an artificial intelligence. And what we do with our platform is take the actual network traffic, basically create the metadata. So we basically use the packets coming in as machine learning, and then interface that into not only our own software, but into other platforms as well. It's the next slide, please. Our data collector, for those who've been around the block for a while, it's called an InfiniStream. And for NETSCOUT, we've merged with Network General, the original sniffer company, to create this platform. And it's very powerful because what we do is take in packets, which again, packets is, if you're talking about machine learning, you're not going to get a better consumable piece of information than for machine learning than a packet. However, taking machine learning, the actual packets itself, and taking it into a big data platform would be very resource intensive. So that's why we take the metadata and have created this platform for this. When we're actually looking at the network streams, we've also combined this to another piece of our solution that we call Ingenious Pulse. Not really important that you know that. What's important is what it does. And that is, not only do we take the observed traffic off the wire, but we also create and run synthetic business transactions. That can be a website test, that can be a phantom phone call, that can be just exercising a multi-tier application. But the bottom line, what we want to take that data into our data collector along with the machine learning for the packets. And again, get these into consumable bytes for user transactions. We have our own platform for Ingenious One, which is the NETSCOUT platform. But again, the key point on this entire slide is the ASI data. That is the machine learning data. That is the artificial intelligence. And hit the next slide, or hit the advanced, thank you. What we do with this, we take that ASI data, and once we've got it in that consumable format, well, now it's open. It's basically an open platform for anybody, whether that's a business intelligence framework, that's a columnar database, or really if a Kafka feed. I mean, obviously every single customer that we talk to always wants to talk about an API. Well, an API means a lot of different things. Could be something as simple as just a straight CSV format, but things are getting a little more interesting now in terms of Kafka feeds. And pulling that data into bigger platforms. So while you've got very rich data coming off of the network, getting it into a consumable format that you can use for business processes is kind of a big deal. And again, the use cases can be applications. The use cases could be cybersecurity, which is really where we see a bulk of where our focus is right now. In Elastic searches, because part of this is because big data platforms are usually so fast at crunching data across different data sources that come in, it's much faster than just doing anything manually, obviously, and we want to fit into that platform. And because our basic business model is going after the triage market, the quicker you can solve something, a user's problem, the quicker you resolve it, you get your ticket over. But bottom line, you get it back over to the point where your services are restored and your users aren't impacting. So you're not impacting revenue, you're not impacting productivity. That's the whole name of the game. Hit the next slide, please. So as we get into the, again, I've talked about the smart data, and that sounds great, Mr. NETSCOUT guy. What does it actually mean? Well, as I mentioned, we get our data set actually starts from a packet, which is the actual ones and zeros that fly over the network. And obviously, coming from the network and network general background, that taking those consumable formats for all different protocols, all the network traffic, all the application traffic, and taking that into a machine learning platform allows you to get all the richness of that information, but yet, let's call it, not nerd out about it. That's my technical term for that. And when you start looking at the different use cases about in the old, we go back 20 years and we talked about 10 meg shared, 10 meg to megabit Ethernet shared networks. These weren't problems, but now we've got ultra virtualization, ultra complexity, ultra software defined networks. It becomes real interesting when you're taking this data and then taking it across your infrastructure, your private cloud, your public cloud, your hybrid cloud. It's all over the place. So the challenges of today's multi-tier applications are not just confined to one data center or two. Sometimes it's across data center platforms, it's across the public cloud and the private cloud. So it gets very, very difficult to take all this traffic across and actually get into a triage process. What we do is take the data set, whether it's been deployed physically inside of the data center, or if it's been deployed, I should say, as software inside of the private cloud. So inside of VMware, where VMware where you may have one particular host, but one ESX host, but it's got 50 guest operating systems running inside of it. That's a lot of east-west traffic, as we say in the network world. And what that does is that's great. It's great for utility. It's great for getting all the value of your compute space, but it's very difficult when it's done, when it becomes triage time. So taking the data from those different platforms is really a big deal. I like to say we've grown up as a company, much like the world has grown up. It's very focused on software now. So even though the InfiniStream is the data collector, can be an appliance to take all of this data, which is fine. In today's world, we start talking about virtual platforms, be it private cloud, VMware, things like that, but also things like NSX and ACI. You've got software-defined platforms where you've got more data sets coming, so the metrics that you can collect and collaborate and use from a business standpoint are just growing. The key point is data collection. So making that software available means that I can be inside of a private cloud. I can be inside of Amazon, and I can still see all of your application traffic as it's traversing your infrastructure that you pay the cloud provider for. And not just the network layer, but actually the individual pieces of the application. So a web tier, a database tier, an application tier, interfacing with DNS and DHCP and other things that are more geared towards network services and authentication. That's a big deal when you're looking at this whole thing as an entire service. And when you're putting pieces of your compute in your own data center, pieces of your compute in the cloud, pieces of your compute into virtualization, having that basically one view where you can see all of the network, all of the application view is a big deal. And taking that data into other platforms, as we're talking about today for machine learning and big data, taking into other platforms is the win here. It's one thing to be able to triage things, and that's great more for IT operations. But I want to take that data and I want to take it out for a spin. What can I do with this? What things can I predict with it? What business analysis can I do with it? And because you're at the ones and zeros level on the actual network, it means that it's kind of the creme de la creme as far as data sources go. You're not going to get something richer than a packet going across the network. So what does that actually mean in terms of platforms? Well, it's not just VMware. That's actually things like Kubernetes and other platforms that are continuing to grow as the vendors the cloud providers are offering up other vendors that are make the utility computing even more efficient. We have to be able to take that data because the applications still run. There's still response time involved. So the metrics that we take, it's not just something as simple as utilization. It's actually taking something where we're looking into the actual protocols themselves. And I know this is a bit nerdy, but we got to go down one level. The protocols themselves are smart enough to tell you where they're broken. What you need is something that you can actually, at a glance, without having to go into a traditional packet decode and collection mechanism, and actually go through that skill set. By machine learning, we take that data into our engine, we do that right off the bat and start, where do I see utilization issues? Where do I see response time issues? Which protocol? What are the error codes inside there? Is this an encrypted stream of traffic, and do we need to unencrypt it so we can get to it? Are we having problems in our call centers? It opens up the door to what's possible here, because now you're not limited by physical infrastructure. You're limited about where's your instrumentation, and that instrumentation can be hardware or software. But the value of it, it's not just network. You're looking inside the applications themselves. And you can customize these, the way our format is set up. We can customize this so that as we're running through our machine learning process, whether it's a known protocol like something like HTTP or HTTPS or DNS, but it also can be some things that could be bigger than that. If you've got your own, in your particular industry, if you've got your own protocols, could be financial, could be in the utility market, could be in the healthcare market. We focus on all of those, but the ability to extract out that metadata so that you can use it for triage is one thing, and that's great. But then taking it up a notch, and then where can I start predicting where I'm going to have slowdowns, where I'm going to have issues, where I'm going to have capacity issues? That's where we're on our way to. So our focus with our customers is really to not just collect that data and certainly use it to triage and make sure that the services to the company and your customers are up and running. But more importantly, how can I share that data and get more value from it? Not just for triage, because after a problem's over, what do you do with it? Well, obviously you can generate baselines and alarms and anomalies, as Tamera had mentioned earlier. But I want to be more predictive with it. Where else can I go with this? How can I see this, that I am going to have a call center issue in Manila based on these timeframes and these types of use cases? This is where we're taking our data to, because it's less about the data anymore. It's really about the information. And because we've got options here in terms of where that instrumentation footprint can go, you can follow the applications as our customers do, as you do. as you go into cloud and virtualization platforms, you're not limited by that. It actually expands things. Get the next slide, please. So again, don't want to take it down to the nerd level, but I've talked a lot about machine learning and big data platforms, but I've given you no information, no real meat to it. So we wanted to have just one screenshot, really not to showcase the NETSCOUT platform, but really show you what we're capable here in terms of metadata. So this happens to be the DNS protocol. We chose DNS. I saw that Luke Teeters was going to present on DNS afterwards, so we thought this would be a nice lead in. So when you're talking about DNS, there's lots of, and DNS is, for those who don't, that's a domain name service. So when you type in, I want to go to espn.org, you type in espn.com, the name resolver goes out to the name server, domain name server itself, and then allocates, it pulls the IP address and then sends your browser where you need to go. Companies have them internal. You're using them. We're all using them for our browsers as we're all working from home as well for our local service provider. Well, when DNS doesn't work, it's basically the first step in a very long process for multi-tier applications, meaning if DNS is slow, everything's going to be slow afterward because DNS is going to be slow. It's going to make a call. It's going to fail, go to the next one. Users don't see all the back-end action. All they really know is, hey, XYZ application is slow. So again, from our viewpoint, as you look across the top here, we're looking deep into the nerd knobs. That's a hashtag. It's a beautiful thing to have these types of things. I use it as a badge of honor. But I want to get into the nerd level because if I can't tell what is inside of the DNS packets, what is inside the actual request of what went through, not just how many bytes and packets, I want to know what did Ken ask Tamera, what was the call for espn.org, what server did it go to, and then more importantly, what was the response time? But more important than that, what was the actual request back? What was the in that transaction between me and the DNS server? What actually happened? Get the next slide, just make it a little bit bigger. Thank you. So in this case, I asked for espn.org. Well, there is no espn.org. It's espn.com. So the DNS server is going to say, sorry, Ken, I don't have that. That's a failure. That's a name error. Now, again, you're looking into the protocols for these, and we're using DNS as an example because it's so commonplace. This could be any protocol. And frankly, it could be even ones that your particular industry may leverage, or you may have your own custom protocols. The reason we bring this up is because if I can tell where the protocols themselves are, forgive the expression, burping or having issues, then it means I'm already down my triage process. I hate the word root cause. I love the word probable cause. I want to get it to tell me where I have slowdowns, tell me where I've got errors, because that's going to be a logical next step of where I'm going to start my triage process. And again, this can go across any protocol family. Can you hit the next slide, please?
It's at 2 minutes. Just give you a heads up.
Yep, actually minute 30. I'm timing myself. How about that? Thank you, though. The reason that we bring this up is, again, machine learning and big data platforms and leveraging it for service triage is one thing. But what does that really mean? Where do I want to take this to? Well, as I mentioned, one of the really popular things that we do with a lot of our customers now is they want our data, they want our records, because they see the richness of what it's capable of doing, whether they're a cyber person, whether they're an application developer, where they're a network architect, where maybe they're looking at software-defined networks and really looking to take this out for a spin, and they've got other considerations like policies they need to take into consideration. And so what our methodology is we've got the data, and while we have packets, nobody really wants packets other than cyber people and network people. I want to take that metadata and fire that into big data platforms, either via Kafka feed or via any API. And this slide's from one of the cyber conferences I've spoken at. But the reason we bring that up is because if I can make your SIM, which is basically a cyber operations platform, you've already got data going into it, syslog, other flow-based data. If I can take metadata from packets and actually make it all the better, that's a good thing. And our message to all of you is not only can this be for cybersecurity platforms, this can be for application platforms or larger big data platforms where you're taking the network and response time things into your whole view. So with that, I think we're on to our last slide, and we have finished, I think, on time. Look, my timer even went off. Look at that. If you have any follow-up questions, I'm sorry.
No, good stuff. Good stuff. Thank you. That was Tamera and Ken. And next up is Luke Teeters on DNS. Excellent. I see this is working. So whenever you're ready, Luke.
Yep, sure. Can you guys see my screen?
Yep, I can see it.
Okay, can you hear me okay?
I can hear you just fine.
Okay, great. All right. Hey guys, so my name is Luke Teeters. I work for Palo Alto Networks as a systems engineer, but that's about all I'm going to say about Palo today. I'm actually a graduate student at Penn State University as well, studying cybersecurity. Today I'm here to talk to you guys about DNS in depth, specifically DNS records and how you can use them for security purposes. I took some training and they told me to make an individual slide. This is basically me and my family. I got some certifications, you know, I'm a musician, I live in the Cleveland area. So that's about it. So today in the agenda, I'm gonna try to squeeze this into 20 minutes. I've done this talk for an hour before, really getting into the nerd knobs and the weeds. So I'm gonna try to rush through this and just give you the high level valuable information. What I'm about to show you is not a product per se, this is just the DNS technology and how it works. I'm not going to get into the actual DNS configuration or how the authoritative DNS is configured. That's kind of just a prerequisite of what I'm talking about. But I'll put a little seeds in there just to kind of mention what I'm discussing here. So we're going to go over domain ownership. What does that mean, domain ownership? We're going to go over the domain name system, specifically authoritative name servers and the records that are in the authoritative zone. And then we're going to talk about DNS security records specifically. And this is where the meat of the presentation is. Again, no products. This is something you guys can do at the end of this discussion. And I do have some action items at the end that you guys can actually take back to your current place of employment to actually use some of this stuff. So how am I relevant? You know, Luke Teeters, I'm a young guy. How am I relevant here? Well, I actually, matter of fact, used to work with Doug here at a startup company. And I actually left the startup company to go work with one of my professors that I was studying under. And when I walked into the door, they actually had a guy that worked there for 20 years retire. And he handed me the domain name system and the domain ownership. So it was a big responsibility for a young guy. Gets better. The CIO comes, a new CIO comes in and he wants to move our on-prem data center to a co-location. Now the problem is we had a DMZ at our data center in our building. The IP address was going to change for the DMZ segment at the new co-location. The other issue was our authoritative domain name servers were actually in that DMZ. So the first thing that had to get moved was the DNS before we could even think about moving the data center. Otherwise, that data center would still have to be up and operational. So I actually had to migrate 100 plus domains from the on-prem DMZ to this new, what I selected to do is actually go to the cloud to do this. One thing I found that was very interesting with the domain name system that a lot of people don't understand is that as of June 2020, there are 1,514 top level domains. So you heard .org, you heard .com, but there's so much more. I actually went out and registered, my last name is Teeters, .family. So if you email luke@teeters.family, it's my email address. It's very interesting. This is kind of where the internet is heading. There's .bicycle, like .net, .site. There's a ton of them. Go check it out. You can actually go to Google right now. Google is now a registrar. You can actually purchase domains for $10. And the TLD, the top level domain, is not .com. It is not .net. There's very interesting ones. .io is a very popular one these days with startups. Highly encourage you to take a look at this. And how can we actually think about this from a security angle? So I wanted to point out 3 things I thought was interesting. In early 2019, there was a government shutdown, I believe, and all the administrators went home. As soon as that happened, a lot of people started calling registrars and tried to get access to the domain ownership of .gov websites, .gov domains. What this led to was actually people getting access via just vishing, which is basically tricking someone at a customer service desk to get them access. And then they actually altered DNS records, which would cause a user to be redirected from a legitimate website to a nefarious website, maybe a clone. This was really bad. So what they did was they actually responded with an emergency directive to actually go ahead and within the next 10 days and verify your DNS zones, all the records, to make sure they're valid and proper, but also change your passwords. So I thought that was extremely interesting because some of these portals, like GoDaddy's a registrar, Google's a registrar, they have multi-factor. They have the ability to assign multiple accounts and give different permissions. This is something that people don't necessarily think about unless you're faced with it as part of your job. The other thing I wanted to mention is domain renewals. When you purchase a domain on the public internet, you actually have to keep up with ICANN and pay for it. So again, back to that 100+ domain list, every single month we had multiple domains come up for expiration, right? So someone actually had to renew these every month, and that was me. So long story short, what I ended up doing was moving the domains, the 100+, off of like several different registrars to a single registrar known as CSC, and just had them take care of it. I basically outsourced that menial task. It's a pain in the butt having to log into these portals every single month and renew domains. So those are the things that I wanted to mention for consideration when you actually own domains on the public internet. Another thing to consider is typo squatting. So there's a tool out there called DNS Twister. If you just Google DNS Twister, if you type in your company's domain, it'll actually typo squat that domain with zeros and ones and different leet speak, if you will, and spit out a list that will actually tell you if the domain was registered or if it's just available. Now, I just mentioned there's 1,500+ TLDs. It's not possible to purchase every single domain. It's just not possible. So basically, it can actually spit a CSV file out for you. And what I did as a security practitioner was put that on my firewall for blocking. And I thought it was interesting. InfraGard, which is a local group in Cleveland, actually had this happen. InfraGard.com was registered and was being used for nefarious purposes. Here are some cloud-delivered authoritative DNS providers out there that you can actually go and pay them to host your DNS for you. Just wanted to mention, there's tons of providers out there. Okay, so here's the meat and potatoes, if you will. These are the different records we're going to discuss, and I'm trying not to get too technical here, but I'll just give you a good idea for what they do. So there's SPF, DKIM, and DMARC. These are the three important ones for email. BIMI is something that is new that's coming to the market. We'll discuss that. These are all published using DNS TXT records. So in the DNS world, there's different types of records. We're just going to pick on TXT records. And then I will mention there's a new record type called CAA. It's the Certificate Authority Authorization Record. This is interesting as a developer because if you have a website and you issue certificates for that website or that service, you can actually publish a DNS record and restrict which certificate authorities can publish certificates for your domain. It's very interesting. This prevents rogue certificates from existing. Here's a sneak peek at the Teeters.family root zone in Google. So I purchased Teeters.family at Google, and Google just so happens to be a DNS provider as well. So they're actually providing my DNS resolution for me. These are the records that I have today. As you can see, several TXT type records with content, a CAA record with content, and then MX for my mail. So I'm sure some of you have heard of SPF. This has been around since I think the 90s. But basically what this does, this is the sender policy framework. You basically post a single TXT record in your zone saying where your email should source from an IP perspective. So to give you a sneak peek of what that actually looks like, at the top there, that is the actual readout for the Teeters.family SPF record. So as you can see, V equals SPF1, that's just the version, include, and that's actually a DNSA record. Now, as you can see below, there's a second query, which expands it out. So these are all the mail servers for Proton Mail, which is the service I use in Sweden to host my email. And then at the end, there's a -all. What that means is I'm telling whoever receives mail from me that if it doesn't come from this list of IPs, spam it. Okay, so this has been around since the 90s. This was basically step one for preventing someone from spoofing your email with your domain. Now, I could still do that, right? If I wanted to pick on your company, I could spin up a mail server and I could send email from your domain. Now, this protects, once it's received by the recipient, they can check the domain's actual SPF record. Hey, that didn't come from any of those IPs. And add it to the spam or quarantine. Again, this has been around forever. DKIM. Now, how can you validate that the content of the message wasn't altered in transit? This is where private public key pair comes into play. As the mail leaves the door, it is hashed with a private key. The public key is published in the domain name system. So this is what that looks like. It is, again, a TXT record. As you can see, V equals DKIM1. This is signifying that it's the first iteration of DKIM. K flag is for RSA, and then P is the public key. And that is the public key that I would like users to be able to leverage to verify and hash the mail as it's received to verify that it wasn't altered in transit. One thing I wanted to mention, there is a selector value. So what I mean by a selector value is, as you can see in the red mark there, Proton Mail is a selector. _domain key the domain. What this allows you to do, if I hosted my email in Office 365 for my users, but I use Salesforce and Salesforce sent email as on behalf of my domain, I could have two selector values. I can have an Office 365 selector value, and I can have a selector value for Salesforce. This allows two public private key pairs to hash the message out the door, and that could be checked via the DNS once it is received. Again, this is basically verifying that the contents of the email message was not altered. Now, imagine someone doing a man in the middle between the sender and the receiver, altering the hyperlink in the text. The user clicks it, now they're on a phishing website. It's not good. So that's basically what DKIM does. DMARC. Now, that's great and all, but what if you configured it and you started, your recipient started to quarantine your mail? You would kind of want to know. And also, if someone was out there on the internet spoofing your domain, you would probably want to know that as well. Where did it come from? I want that email header. The only way without DMARC is if someone forwarded it to you. Hey, Luke, someone sent me this email message. It doesn't look right. Was it from you? No, it wasn't. Can you send me the email header? Then you get the IP where it's sourced from, all that fun stuff. What DMARC allows you to do is, again, it's a TXT record that you publish in your domain name system. Again, very similar to SPF and DKIM. It is V equals DMARC1. It's the same format. And notice that there's a P, that's the policy. And notice mine is set to reject. What this tells the recipient is, check SPF, did it source from the IP? Yes, it did. Okay, check the contents of the mail message with my public key. Oh, the hash matched. We're good, check, check. I'm going to accept the mail. But if someone sends an email from a nefarious source or alters the mail in transit, if it doesn't match, I'm telling the recipient to reject the mail. I'm saying, hey, don't even mess with it, reject it. Now here's where it gets interesting. The part after reject, the RUA, that is an email address. What DMARC allows you to do is receive reports from the recipients on a daily basis in a .xml format of what mail they received from your domain. So basically, you can actually either use an open source tool to look at this .xml file, or you could use a SaaS service and have them receive those .xml reports on a daily basis and display it for the security team. This is very interesting. When I configured this in an actual corporation, I was seeing email sourced from Russian IP addresses for my company's domain. How else would I have known that happened? And if you receive these email messages, then you can contact the service provider and say, hey, someone's spoofing mail from that IP address. I want you to shut that down. So again, this is just DNS records so far. Now here is something that's interesting, and it's coming. It's called Brand Indicator Message Identification. It's called BIMI. It's currently in a pilot. So Google and Yahoo are actually involved in this. And this has been gaining traction over the years. But again, it is published with a DNS TXT record. So as you can see in the center there, I actually have this published for Teeters.family. What this allows you to do is host a logo for your company in such a way that if SPF, DKIM, and DMARC pass, when the email arrives at the user's inbox, it will actually have the logo for your company next to the email message, signifying this was legitimately sourced from that sender. I put a picture of a bicycle, as you can see in this illustration on the right there. But again, you have to be in a full reject state with your DMARC policy. Now, I know I'm throwing a lot at you. I can share this with the group at the end, but I just want to make everyone aware that this stuff exists. Again, no products. This is DNS. That's it. Just publishing this in the zone. One thing I found interesting today, actually, when I was reading into how Google is handling these logos, they actually require you to go out and purchase a what they're calling a VMC, a verified mark certificate, saying that you own the intellectual property for the logo. So I thought that was interesting. Imagine you get an email from a company, their logo is next to it. You know that it was fully vetted, it landed in the inbox, and the logo itself was even had a certificate. Okay, so now I'm going to move on to SSL certificates. How am I doing on time, Doug?
Got 4 minutes.
Okay, I'm gonna try to get through that.
Change.
So I mentioned CAA record. This is a new record type. This is interesting. The CAA record type was published to the internet, and it was certified, I believe, in 2017 from the browser forum. But basically, what this requires certificate authorities to do is, if I want to generate a certificate from GoDaddy, and I have a CAA record published in that domain, GoDaddy has to be listed. If GoDaddy is not listed and someone goes to try to publish and generate a certificate, it will be rejected immediately. So as you can see, I picked on nasa.gov. I did a dig for the CAA record type, nasa.gov. They don't have one published. If I do one for teeters.family, I have a let'sencrypt.org listed. What this means is Let's Encrypt is the only certificate authority that can generate certificates for my domain. Again, this helps thwart the developers out there from generating certificates without the security team knowing. So this is actually a pretty nice control. And again, it's a CAA DNS record that you create in your authoritative zone, and that is it. The last thing I wanted to mention was there's a Google transparency report. So as a cybersecurity analyst for a company, you can actually go and type in your domain. It'll spit out a list of every certificate it's ever seen on the internet, expired or current. So this helps basically catalog what's out there and what has ever been used. And for the final piece, action items. One thing is, a lot of people don't know the individual or team who owns and renews the corporate domains. Go find that person and ensure that they're using multi-factor on that login account, because that's the last thing you want for these large organizations in our city, is for someone to gain access to that and alter. That's endgame. That is the worst thing that could happen as far as getting hacked is concerned, in my opinion. Second, check DNS Twister for typo squat domains. If someone went out and typo squatted your domain, you would probably want to know about that. It's a free service. Export the list, block it from your users from interacting, email, firewall, URL, etc. And research your own domain. Do you guys have a SPF, DKIM, DMARC, or BIMI record posted today? If you don't, you should probably start implementing it. There's no cost here. This is something that you can do today. I've done this, and I can tell you that it's actually a lot of fun, because once you start publishing this and you start getting DMARC reports, you're like, wow, that's interesting. And I think that is it. Thank you so much today for your time. Really appreciate it. I'm sorry for kind of shooting all this at you quickly. Typically, I go over the authoritative DNS and how that looks and how it's configured. But I was happy to speak to the chug today. And thanks for your time.
That was awesome. Thank you. We've got about a minute left. Does anybody have any questions? If you do, please type them in the chat. And that the people trying to grab the .gov domains, I mean, wow, that is bold.
Yeah, Google it. It actually happened. People actually gained control of .gov domains, and they were actually altering DNS records. And when that happened, they were actually redirecting legitimate, state websites, government agency websites, and it caused that emergency directive to be published. this is reality, guys. This happens, right? I'm not a hacker. I'm on the blue team side, but if I was, this is something that I would go after.
That is terrifying. With that, everyone sleep well tonight. I'm kidding. No, but seriously, Luke, thank you so much. It's a great defensive information. We'll go on to our last talk with Arista. Joe and Chuck from Arista are going to be presenting. So whenever you're ready.
Yeah, thanks, Doug. Hey, good job, Luke. That was great stuff. Appreciate it. Again, my name's Chuck Messina. I'm the Regional Sales Manager for Northern Ohio, based here in Akron. And we also have Joe Malinka on the line, who's an SE Director with Arista Awake. Thank you again for the opportunity. For those who are not familiar with who Arista is, and I guess one of the main reasons why we've been part of the Big Data Meetup group here in Cleveland for the past 7 years, is we are the big data company for networking. As a quick introduction, you know, Arista has brought to the table a network operating system that has a central database on it. So what we are bringing to and what we've brought to many of our customers is a network device, whether it's on-prem or in the cloud, that has a central database on it. Now, this is not a MongoDB or a SQL database. It's just a structured tree of data that keeps what's going on within that network operating system down to the millisecond. Now, what we're doing now, because our Arista believes in open standards, we do not believe in proprietary protocols. So what we do is we, via OpenConfig, ship that data of what's going on within that network operating system, of what's going in within that router or switch or virtual switch in your AWS or Azure clouds. We ship that information down to the millisecond to a network-wide database. And that's why we purchased Awake. Arista purchased Awake about a month and a half ago. It's a network intrusion and response system. And we're very excited to have them on board and be able to ship them this data from our network switches and routers. Joe, I'll kind of hand it over to you. I'll give you the ball, and you can kind of talk more about what Awake can do for us.
Absolutely. Thank you very much, Chuck. And so the Awake is focused on a few major problems in the security industry today, and that is that there is an increasing amount of IT and IoT devices that are proliferating that are beyond the reach of management. And so these are types of devices that don't have agents on them, and they are, for the most part, outside of the full control of those that operate the network and are tasked with securing it. And so the real focus with Awake is to identify all traffic that's going in and out of the network, to figure out what devices are communicating, and then to look for malicious intent within those communications. So if you think about many of the problems today as it relates to information security, more than half of the devices are unmanaged, right? Not running any agent and just outside of many of the controls that they're had outside, you know, perhaps not including like, you know, just firewalls and whatnot. But once you get inside of an environment as an attacker, it's usually pretty easy to move laterally. And even more than half of the breaches have been without malware, meaning that the attackers are living off the land. They're able to fit in and look just like any other legitimate user. And then the other problem is that most of the traffic is encrypted. And with the privacy laws getting more and more stringent, not just Europe, but even California, right? There's an immense amount of loss of visibility for those that have relied previously on decrypting traffic to be able to see what's going on. And so Awake leverages a very different approach to detect malicious intent. First of all, we're looking at—
Hey, Joe, but just for real quick, can everybody see the screen? I can see this fine. I had somebody just posted that they're having trouble seeing the screen. Is everybody okay?
I can
Okay,
see
Matt
it.
says he can see. Okay, so it must be a local issue. I apologize for interrupting,
Yeah, no worries.
but it looks good on my end. Sorry about that.
Sure, no problem. So the first point is that we gather the different data types from the traffic headers, from the traffic metadata, and we capture all of that and store it locally, and then build a security knowledge graph. Now, being that this is a big data conference, I'm sure most of you are familiar with with knowledge graphs. Similar to the approach, I mean, when Google first introduced it over a decade ago, and basically building relationships out of different elements of search elements, we're doing the same thing out of network data, right? Building an immense security knowledge graph and being able to use that to track devices as they go across the network. Not creating a baseline, but looking at what is uncommon about devices. What is infrequent? What makes this device unique relative to other similar devices or all devices on the network? And using the background as the baseline. And then we take that data and analyze it using a built from the ground up modeling language. We call it the adversarial modeling language that allows us to query and ask any question of the network. So not, I mean, at a high level, you look at it and say, oh, this looks kind of like Wireshark or like Splunk or like other query languages you might be familiar with. But at its core, it's fully functional, fully programmatic, in that you can run any type of function or even make the different data types interact with each other to infer new types of answers, right? And finally, there's the hunt component. So we have a component called AVA, which stands for the Awake Virtual Assistant, which is essentially like an Alexa for your network security team. In being able to ask these questions, but also automate much of the triage work that they do, whether it's a tier 1, tier 2, or tier 3 analyst, whether they're doing IR, forensic investigations, or incident or threat hunting, being able to automate that, so removing hours of time each day from the analysts and making that only take 5 minutes, and giving them results instead of with hundreds of clicks, giving them results with just a handful of clicks. And so that's really the basis for Awake, and looking at big data from all this massive amount of network traffic that is moving in and out of the network and laterally across the network. So the structure is that there are sensors that capture the network traffic, whether it's on-prem in data centers or at branch offices or hospital or wherever it might be, as well as cloud taps, so Amazon, GCP, and Azure, and gathering these full packets of all the network traffic that passes through and out of these networks, and then sending the data to the nucleus for analysis, and having AVA do its work to identify malicious intent within that network. And so the goal here is that we're able to make it much more efficient for analysts to be able to do their job, to be able to identify any type of suspicious behavior in their network with a higher degree of accuracy, with more signal to noise, greater signal to noise ratio than what they've ever been used to before. So they can come in here and ask questions such as, tell me about what's going on from a C2 perspective, or data exfiltration, or lateral movement, or if someone's taking advantage of SM bleed, some of these big vulnerabilities. I'm sure some of you have heard of zero logon back in September, and then a few weeks later, bad neighbor. These are big vulnerabilities that when they get announced, there's no detections in place to see if anyone's exploiting them. And Awake is able to very quickly build advanced queries to identify these types of exploits and malicious behavior that would otherwise go undetected. So some of the other models that we have in our system fall much around, if you're familiar with MITRE and the attack framework that they have, or the kill chain, as far as going from the initial stages of an attack to the final data theft and espionage. So we have over 1,500 out-of-the-box recipes, skills, models that detect different behaviors. One of the things that was just brought up on the previous talk was about DNS, basically typo squatting. And so we're able to, for example, we call it doppelganger, right? And so if we're looking for domain exclusions, where someone, if they're at example.com or companyabc.com looking for small, slight changes to those types of domain names that might be used in attack against the employees, right? And so we're able to identify when an attacker might be using those types of doppelganger or typo squatted domains to socially engineer an employee to click on something and get them to give up their credentials or to somehow get access to an environment. So some of the case studies that we've had is where there was a financial here in New York City. We were brought in and they had 8,000 Polycom phones. And we were able to identify that 4 of those Polycom phones were doing something very differently than all the other Polycom phones. And it turned out that a third-party contractor had modified, had basically turned on debug mode on the CFO's Polycom phone to record sensitive conversations and then sell those conversations, recorded conversations, on the black market. So this third-party contractor wasn't engaging in insider trading directly, but was facilitating it and profiting off of that insider knowledge by selling it to third parties. Needless to say, that case is still in court. But yeah. So the point in all this is we can figure out what the devices are. We can figure out what makes them unique. We can figure out what threats they pose to the company. And then we can make those alerts actionable so that when an attacker, when an analyst is viewing these behaviors as they occur, they're able to stop them immediately and take action. So we have integrations with third-party SEM like Splunk and Logarithm, with SOAR like Phantom and Demisto, with even EDR endpoint agents like CrowdStrike and Carbon Black and Sentinel-1, and also with firewalls like Palo Alto, where we're able to integrate and using our detection logic, then go out and enforce and stop such behaviors when they occur right from within the Awake security knowledge graph, right from within the Awake UI here. The last thing I want to point out is the automation element, and that is where we can come in here and look at what types of automation we can do to enable network analysts, security analysts, to be able to do a lot more than they otherwise could without this high level of automation. So in this case, we saw a specific user, Aokley, with the machine name of sys3690 there, was doing some reconnaissance and even copying data from these 5 other machines here. Well, Ava can automate that and go forward in time and backward in time looking for other potentially related behaviors. And so here, it was identified that Aokley was actually doing a Kerberos brute force attack against a domain controller. And then an hour and 15 minutes later, roughly, once with the stolen credentials, was starting to steal data from these machines. And then a day later, exfiltrate off to an appspot.com subdomain. And so with all of that, rather than have the dependency of a network security analyst trying to figure out, okay, what really happened here? Did we make sure that we found all of the victim machines, or did we miss any? What happened before this? What happened after this? Being able to look at all of these behaviors and tie them together into a more meaningful story rather than a single alert makes the life of a security analyst so much easier and allows them to be much more efficient and keep the organizations that they protect safer to a much greater degree. So thank you very much for your time. Any questions or comments, we'd welcome those.
Well, this was terrific. One of the things I was thinking of was I saw a talk in Cleveland 2 years ago. There was some well-known hacker, I'm blanking out on the guy's name, who did a talk. And he was talking about printers as an attack vector. And he goes, oh yeah, he goes, those are huge risks because people forget that they're actually computers. And your comment about the phone made me think of that, because it's all the odds and ends that people tend to forget to secure or monitor.
Yeah, right, Doug, and especially with IoT,
Yeah.
Especially in the move to 5G, most of the factory of the future is moving to 5G. With legacy tools, how are they gonna, see what's going on within those environments?
Yeah, and another one was we detected, we were engaged with an oil and gas company here in the United States, and they said that they got an alert from their endpoint agent about some sophisticated attack, but when they went and actually investigated that endpoint, it didn't look like there was any malware on it. And so they were worried that the attackers had gotten in and quickly moved to a different machine and covered their tracks by erasing any traces that they were on that endpoint. So we were called into that, and by monitoring their network, we were able to uncover that the Russians had actually gotten into this oil and gas company and had moved quickly to security cameras. So they were using the security cameras as their place of residence, from a cyber perspective, and they weren't even on a managed device, right? And so without just by using your tools of managed devices, you wouldn't be able to see what's going on, but we were able to detect that. Yeah, and then another one, we saw a power company, a utility that had a SCADA network, and in this case, we saw two devices that were streaming streaming down to the two devices, massive amounts of encrypted traffic. Well, it turns out that the team of engineers running that SCADA network, they wanted to get some exercise in, and so they brought in 2 Peloton bikes and connected it directly to the SCADA network, on which the other, very important utility servers were on. So we've found funny stuff, and we've also found very serious stuff, and even a Tesla connecting to a corporate Wi-Fi. Really crazy stuff. But without this big data analysis of the network traffic, it's very challenging to see.
Oh, this is fascinating. The perimeter is the perimeter mindset. I mean, just all your examples is dead. You've got to assume that someone's in there already, and how do you find them?
Exactly. So assume that you're compromised, but make sure you have the tools to be able to identify those that are in there. That's spot on.
So we got 1 or 2 minutes left. Does anybody else have any questions? Just put them in the chat, please. If you do, we'll give it a second. Looks like we don't. Wait. Okay. Just not a question, but a thank you from Sunny, saying I really appreciate the insight. Joe and Chuck, thank you very much. This is fantastic. And again, I want to thank you. Thank all our speakers. Give them a round of applause, virtual or otherwise, or real. Thank you so much. And this will be posted in a couple of days. Again, thank you for attending Cleveland Big Data. It's the community that makes this possible. So we'll see everybody. Stay healthy, mask up, and we'll see you in 2021. Thank you.
Thank you, everyone.
Thank you. Stay safe.